Now, so that's the first thing that special relativity is based on. Now let's go to the second thing. So what's the second thing that special relativity is based on? Something that we actually already mentioned last time. Here we go. No matter what constant velocity you have, the speed of light is always the same. And by the way, when I say no matter what constant velocity you have, I mean no matter how fast you are going, no matter how fast you're going, the speed of light will always be the same. Okay? The speed of light will always be the same. Okay. Now, here we go. This is going to start making things weird, okay? This is going to start making things very confusing. So let me go back to the train. Okay, I'm back on the train. Let me get this out of the way. Here we go. And this time, again, you guys are down here. I've actually lost my people. So you guys are just sitting at the station watching this train again. And this time, I am parked at the station. So, while I'm rebooting this document cam, let me ask you guys this. Again, this is going to be a repetitive question. How fast is the train going relative to you guys right now if it's parked at the station? How fast is the train relative to you guys? I'm getting some weird lighting coming in up here. Again, yeah, 0 or nothing. 0 or nothing, right? And, okay, again, relative to me, what's the speed of the train? From my point of view, relative to my body, what's the speed of the train? Still 0, yes. Still 0. We both agree on that again. I'm not moving. Okay, but this time, instead of throwing rocks off the front of the train, what I'm going to do is I'm going to shine a flashlight off the front of the train. Okay, let's say that's the front of the train over there. So let me get my flashlight. Where is it? Here it is. Okay, wait. Wait. Flashlight too big. Let's, there we go. Okay. There we go. Okay. That's better. Okay, now. There we go. I got my flashlight. Boom. Okay. So, I got my flashlight. And what I'm going to do is I'm going to really quickly flash the flashlight. So, beep, beep. I just on, off. Just, psh, I just let some light out. Just, psh, psh. Okay. Now, I let a little burst of light out the front of that flashlight. Don't overthink this. What speed will I see the light go off the front of the train? What speed will I see the light go in that direction? The speed of light. Yeah, I would see it go the speed of light. Okay. And what speed would you guys see the light go? What speed would you guys see the light go? Also light speed, right? Also light speed, yes. Also light speed. And by the way, how fast is light speed? Light speed is about 300,000 kilometers per second. So it's very, 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 very fast. Way faster than the rock I threw, okay? But boom, the light came out. Okay, now, different situation, okay? Different situation. Now, my train is moving again. So let me get my motion lines on here. Okay, got my motion lines, but I'm going to put way more motion lines because this time my train is going really fast, okay? Really fast. How fast am I talking? Let's say that my train is moving that way at 99.999% the speed of light. Okay. There we go, right there. So I am going 99.99999% the speed of light. I'm going a ridiculous speed, okay? Ridiculous speed, okay? So now, though, check this out. Relative to you guys, you see me just fly by at 99% the speed of light. From my point of view, though, I'm still on that train, so that train isn't moving away from me. It's still zero. Whoa, relative to me. There go my glasses. There we go. All right, it's still zero relative to my body, okay? Now, here we go. While I'm driving past you guys, I turn my light on. So, and I just on off, just send out a little burst of light, because this is how flashlights work. Now, okay, what speed, don't overthink this, what speed do I see that light shoot off the front of the train? What speed do I see that light shoot off the front of the train? Light speed, right? The flashlight hasn't changed at all, and it shoots light at light speed, so I see the light go off at light speed. And so I'm going to see that light go way in front of me. After 1 second, I would say that the light was 300,000 kilometers in front of the train, okay? I'm like, whoa, that light really kicked it far forward. Okay, now, when I was throwing rocks, now what we need to do, we need to figure out what you guys see. And this is going to get a little weird, because remember, I'm on a moving train now, okay? And when we did the example with the rocks, the speed that you guys saw the rock go was the speed I threw it plus the speed of the train, okay? Because I threw it off the front of a moving vehicle. Well, this flashlight is shooting its light off the front of a moving vehicle. So if it worked the exact same way as those rocks, what speed would you guys see this light going? If the train was going almost the speed of light, and then I shot the light off the front of the train at light speed, how fast does it seem like you guys would see this light going? About. Over light speed. In fact, almost twice light speed, because the light was going light speed and it was shot off of a thing that was already going almost light speed. So if it worked just like the rock I threw, then that means this light would be going almost twice light speed. But some of you have realized why that's a problem. What did I just get done saying on the previous slide? No matter what speed you are going, how fast will light go? How fast does light go no matter what? According to what we're saying in the relativity business, no matter what, everyone sees light going light speed. Light will always be light speed. So what that means is that when we're looking at this light, you guys are going to see that light go light speed also. I see it go light speed, and you see it go light speed. And that is weird, because now we're not going to agree on something. And it's going to seem like we just had a paradox, because check it out. If I see it go light speed off the front of the train, then I'll say it's 300,000 kilometers in front of the train after 1 second. But from your point of view, okay, check this out. Here we go. From your point of view, if you saw this light go light speed, you would also say that it went 300,000 kilometers per second in that direction. But how far is the train gonna go in 1 second from your point of view. Because from my point of view, the train doesn't move because I'm on it. From your point of view, how far will the train go almost in 1 second? If it's going almost the speed of light, how far will that train go in 1 second? Yeah, it'll go 99 point whatever percent of that. So it will almost go the same distance that the light did. So, here we go. Let me flip this over, get this out of the way. So I would say, here we go, here's the train. The light ended up this is the light. I would say that it ended up 300,000 kilometers in front of the train. And you would say the light went 300,000 kilometers. But the train started here, and then the train followed the light and went almost 300,000 kilometers. So I would say the light is way in front of the train. But you guys would say, no, it's not. It's like a couple of feet in front of the train. So we would be disagreeing about where the light was. You would say, I would say it's way in front of the train, and you guys would say, no, it's right in front of the train because you're chasing behind that light, right? And so here is my question, and this is where we're going to start getting weird. Who's right? Am I right that the light is way in front of the train, or are you right that the light is just a little bit in front of the train? Who's right? Yeah. We are both right. I'm glad so many of you guys are saying that. So we are both correct. It turns out that reality does depend on perspective. There's two different versions of what's going on here, and they are both correct. But they're only correct from certain points of view. This is correct in my version of reality, and this is correct in your version of reality. Relative to you, you are correct. Relative to me, I am correct. It depends on perspective.